All right, so in section 11.5, we're going to be putting probability and the permutations, combinations, and counting principle all together. So counting principle is when you're doing typically like a lineup kind of thing. So if you're lining up bands, lining up people, and choosing for specific spots, that's what counting principle is. Permutation, that's the P, and combinations is the C. For permutations, order matters. For combinations, it doesn't. And what's going to happen now is that your end result, your answer, is a probability. So what that means, you're going to make a fraction out of your answer in the end. So in this problem, it says, well, how many number of permutations we have where the Rolling Stones are fourth and Beatles are last, and the bottom number is the total number of possible permutations. So here, because we're doing a lineup, so I'm going to make a big thing, on the bottom we have 5 bands to choose from, so we're just finding the total ways that we could arrange these bands. So that's this one. So Kevin, what do I have for the first number? What do I have for the first number? How many bands are we choosing from? 5. So if I pick 1, how many do we have left for this spot? And then 3, and then 2, and then 1. So you guys have done problems like this where that was the question, and that was it, and we stopped. So if you want, we can figure that out on the bottom. Now we get 120. But because it's asking for probability of something, and it's the probability of a specific case, we got to do that lineup on the top. So here, I want Rolling Stones fourth and Beatles last. So for this fourth spot right here, how many bands do I have to pick from? 1. How many bands do I have to pick from for the last spot? Only 1, because we want a specific band. So out of the 5, I've chosen 2. How many do I have for the first spot? 3, and then 2, and then 1. Now to make a probability out of this, we just multiply 3 times 2 times 1, which is 6. Reduce the fraction, and if you divide it, it will give you 1 over 20, whatever decimal you get. That's your probability of having a lineup like that. Next one, a lottery ticket. Remember how I said at the end of this unit, you will be able to know the exact probability of you winning the lottery ticket. And we're about to calculate it. So next time you're buying a lottery ticket, you will know your chances of winning. Florida's lottery game, Lotto, is set up that each player chooses 6 different numbers, 1 through 53. If the 6 numbers chosen match the 6 numbers drawn, the player wins or shares the top cash prize. That's how our Illinois lottery is set up that way. With 1 lotto ticket, what is the probability of winning the prize? The first thing that you should always think about for these types of problems is what is the total? So over here, in how many ways can we choose the 6 numbers? And we've done problems like this. So this is the order doesn't matter. So we're going to be doing combinations. So what's my combinations thing for the bottom part right here? How many numbers do we have to pick from? How many numbers are there? 53. How many are we choosing for each ticket? No, like 1 ticket, but how many numbers are chosen? 6. So why don't you guys figure out what 53 choose 6 is on your calculator? Did you guys get 22,957,480? That's how many possible ways there are to pick 6 numbers out of the 53 available. Now, since we're the top part, that's our specific question that they're asking us. How many lotto tickets are we getting? Just 1. So we're only choosing 1 specific set of numbers. So it's only 1 over this. Why don't you guys divide that and see what you get? 1 divided by, it gives us this number, 4.3, and then e to the negative 5. That means this is scientific notation. It's a very tiny number. It actually means, so there's 7 zeros. And then 4, 3, 5. That's how much of a percent you have a chance of winning the lottery. So this is, like, let's say I move the decimal to here. 1, 2. So this is like trillion, or actually no, 20, like 4.3 millionth of a percent that you have a chance of winning the lottery. No, because the decimal is right here, so the 1 counts for that if we move it over. So it's 7 spots. The negative 8 tells you 8 spots the decimal point would be moved. What if you buy 100 lotto tickets? Are your chances better? Let's do, because it's the same thing, 100 over the 20 million, 957,480. So if I do 100 divided by, it's 6 spots. Its exponent is negative 6, so that means there's 1, 2, 3, 5, and then 4, 3, 5. So this is million. So it's a little better. It's still a little better, but should you still be saving for retirement? Yes. Should you marry rich? Yes. Should you go get a job? Yes. And then continue playing, because your chances are this much even if you buy 100 lottery tickets of winning. That's why it's very, very rare that people, for the amount of tickets bought, how many people win. Okay? Next problem. Why don't you guys read it to yourself? All right, Jacob, how many people do we have in the club altogether? 5. No. A club consists of 5 men, and I know Anthony distracted you, 5 men and 7 women. So my total is 12, but that's not what I'm putting in the denominator, okay? Because it says 3 members are selected at random to attend a conference. Because it says at random, we're going to be doing combinations. Find the probability that the selected group consists of, so we have 2 problems to do. One is 3 men, and then we're going to talk about this one. In how many ways can I choose 3 people out of 12? That's my total. Okay, so your total is 12, choose 3. That's going to be our denominator. And how many ways can you choose? And we did problems like this where that was it. That was the only thing you had to do. But now, because we are being asked about probability, you have to make a fraction out of it. So for my top part right here, the specific case is it has to be 3 men. How many men do we have to pick from? 5. So for the 3 men, for the top part, it's 5, choose 3. That's my numerator. 5, choose 3. So let's figure out the top number. Figure out the bottom number. And then reduce the fraction. Okay, make sure you guys get 10 and then 220. So it reduces to 1 over 22. For the second part, the total is the same because we're still choosing 3 people out of 12. But now this is like a separate problem in itself. 1 man and 2 women. What do you remember the word "and" means? Multiply. Or is adding. Okay, make sure you guys have that. Okay, multiplication means the "and" word. In how many ways can I choose 1 man? How many men do we have to pick from? 5. Choose 1. And we're going to multiply it with in how many ways can we choose 2 women? So it's 7. Choose 2. So let's figure out what those numbers are. What is it for 5? Choose 1. 5 times. What is it for 7? Choose 2. 21. And now the bottom part of my fraction is still 12, choose 3, which is exactly what we had right here. 5 times 21? 105 divided by the 220 total, which reduces to 21 over 44. Why don't you guys try example 4? It works in the same way where you have to figure out the total and then find a group consisting of 2 men and 1 woman. Okay? Take a second to figure it out and then I'll show you the answer to check.